For part 2 then of 8.5, now you're looking for your difference of your means when you don't know your sigma, so you don't know the population standard deviation. Again, you don't need to worry about anything with formulas because it's all going to be on the calculator still. Now, just like we had a 2-sample z-test before when we ran a z-test, we're now doing a 2-sample t-test because we have our s's. Whenever you have S, it's your t-test. Whenever you have your sigma, it's your z-test. The last thing you have to do, though, when you go through your t-test, they're going to ask about pooled data. So you need to say, no, it is not pooled data when you go through it. Just remember the no part, because with that, it's saying if you're grouping things together or not, it just goes into something else that we're not going into. So just make sure it is not pooled data. So looking at example 10, we've got 2 competing headache remedies claim to give fast-acting relief. An experiment was performed to compare the mean length of time required for bodily absorption of brand A and brand B headache remedies. 12 people were randomly selected and given oral dosage of brand A. Another 12 were randomly selected and given equal dosage of brand B. The lengths of times in minutes for the drugs to reach a specified level in the blood were recorded. The mean standard deviations and sizes of the 2 samples follow. Based on past experience with the drug composition of the 2 remedies, it permits researchers to assume that both distributions are approximately normal. Let us use a 5% level of significance to test the claim that there is no difference between the 2 brands and the mean time required for bodily absorption. Also, find or estimate the p-value of the sample statistic. Okay, so we said for our level of significance, it's 5%, so 0.05. Null and alternate, again, null is going to be same thing, mu1 equals mu2. Now they're asking for no difference. If we're testing for no difference, it's the same thing as testing for difference, so doesn't equal. Now we want our t-test, so 2-sample t-test. So stat. And then we're going to go 2-sample t-test. So our x bar 1, go back up here, x bar 1 is 21.8, S1 is 8.7, N1 is 12. X bar 2 is 18.9. S2 is 7.5, N2 is 12, and we are looking at doesn't equals. Again, you want no for your pooled, and then we want to calculate. So now going through this, we have a t-value of 0.87, p is 0.3915. So if I compare that with my alpha, we are greater, so we're going to fail to reject. Now we're going to write our sentence. At the 5% level of significance, there is not enough evidence to conclude that there is a difference in mean times for the remedies to reach the specified level in the bloodstream. So again, it's a lot of the exact same stuff. So I'm going to have you do the same thing for the next one. So now you're going to have, suppose the experiment to measure the times in minutes for headache remedies to enter the bloodstream yielded sample means, sample standard deviations, and sample sizes as follows. Brand B claims to be faster. Is this claim justified at the 5% level of significance? Now, think of what that means. If brand B is faster, you want to take less time to fix your headache. So if brand B is faster, it should take less time then to have your headache go away. So remember that when you're doing your inequalities. So pause the video, go through this, see what you get, and then we'll come back together. Okay, so for number one, we got our alpha is 0.05. Our null, mu1 equals mu2. If brand B is faster, we want to say the time for the first one, or brand A, is greater than the time for the second one, mu2 then. Now we're going to go to our stat, test, 2 sample T, X bar 1, oops, I got 20.1, S1, 8.7, and 12. X bar 2, S2, and 8. Now we're doing greater, greater, and no for our pooled, calculate. So we should have 2.44, and our p-value is 0.0132. So we're going to compare that with our alpha. And we are less than, so if we're less than, we're going to reject the null. So for our conclusion then, so there is enough evidence to conclude that the mean time for brand B to enter the bloodstream is less than that for brand A. Again, the quicker it gets into the bloodstream means you're going to have a smaller amount of time then. I'm going to pause this, go to part 3 then in a new video so you can see part 3 with our proportions.